We know that a rational number is a number that can be expressed as p by q, where q is not equal to 0. This is the traditional definition. An example would be 9 divided by 2. But 9 by 2 can be written as 4.5. What is this form? Yes, it's called the decimal form. Every decimal number can be expressed in a decimal form. This is a very important point. Any rational number can be written in decimal form. But what kind of decimal form can it be written in? Are there different types? Yes, let's look at them. There are two broad categories: terminating decimals and non-terminating decimals. Examples of terminating decimal numbers are 0.52 or 2.75. The digits after the decimal point terminate. They do not go on and on and on. Non-terminating is again classified into two types: recurring decimals and non-recurring decimals. Recurring would be something like 0.66666 and so on. It does not terminate and the number 6 is repeated indefinitely. Since it's repeated, it's called recurring. Even something like 2.777777 and so on is a recurring, non-terminating decimal since it does not end and the number 7 is repeated indefinitely. But does it mean only one digit can repeat indefinitely? No, look at 18.525252 and so on. Here, 52 is repeated indefinitely after the decimal. Since 52 is repeated indefinitely and it does not end, it's called non-terminating recurring decimal. Also, does it mean that the repeating part starts immediately after the decimal point? No, let's look at 7.65232323 and so on. Here, the number 23 is repeated and goes on forever. But the decimal part starts with 65. Even such numbers are classified as non-terminating recurring decimals. The non-terminating recurring category forms a very important category in decimal representation. We will look at just this category in one of our videos. Non-terminating non-recurring simply means that the number does not end and the digits after the decimal point do not have a specific pattern. The best example would be pi, 3.14159 and so on. The number does not end, and even if you have 100 digits after the decimal point, you will not find any pattern or any indefinite repetition of digits. Here's the value of pi up to 100 digits. Look at the digits carefully. You will see no pattern whatsoever in here. That is the reason it's called non-recurring. You can even form non-recurring decimals on your own. Something like 6.20300300030000 and so on. There you go. You will not find any pattern here. Or maybe something like 11.67171171117111 and so on. You take any two-digit number like 30 and write it by repeating the units digit again. The units digit is 0. So we write a 300 and then we add the units digit again and write 3000. Here we took 71, then 711, then 7111 and so on. This is just one of the easiest ways in which you can do it. You may also take 3 digits and continue writing them accordingly. But here's the main point of the video. Terminating decimals and non-terminating recurring decimals together form rational numbers. Non-terminating non-recurring decimals cannot be expressed as p by q, which is why they are not rational numbers.